Welcome to Intersection of Graphs. We've been drawing lots of graphs and quadratics and straight lines and stuff. I wonder if you ever thought, well, how would you actually, without technology, calculate the x and y coordinates of these points of intersection? What about the math behind that? And intersection, of course, means the two graphs have a common point. Okay, so that might be a clue as to how we might find that algebraically. And we're going to do it both ways. We're going to do it with technology and algebraically. So come down here, two parabolas might intersect like that. What would be the equations of these two? You might think about that. And over here we've got a cubic. The blue one is a cubic, and it's intersecting the red one, which is a quadratic, in three places. We're going to go on and look at all sorts of polynomial graphs later on in this unit of work on functions and equations, but right at the moment let's have a look at trying to unpack a method of getting a point of intersection of two graphs, a common point. Okay, what do you reckon? Here's the answer. An intersection is a common point, therefore you want to find that by putting the two y's equal, because at that common point the y calculated from one formula should equal the y from the other, and so should the x's. A common point will share an x and a y. So if we work on the y's, you could work on the x's, but of course why do we work on the y's? Because usually we write it explicitly as a function in x, like y equals, and here's another one, let's say y equals neg x squared. So that's why we equate the y's. They do have a common point, has a common x as well, and if the expression was x equals, we could share the x's between the two expressions. Do you get it? You get the idea of how this algebra comes about there. Okay. Let's go and do some screen clippings here from Hayes and Harris. So you should perhaps have a look at their book and follow through there as well. So find by algebraic means the coordinates, that's the x and y, of the points of intersection. So it's where these two have a common point. So we will put the y's equal. Okay, so this one meets this one where the two y's are equal. Moving these terms across to the left, because you know with a quadratic we always try to equate it to zero, factorise, use the null factor law, all that stuff. So subtracting 2x from both sides and subtracting 8, we get neg 3x take 2x, neg 5x 1 take 8 is neg 7. So we're going to try and factorise this. And they talk here about the product here of the terms. This is called splitting the x term, if you like, and that's not a way I was going to suggest you do it. You could check their textbook for that. I was going to come straight down here and say we want two numbers multiplied together to give neg 7. So it's neg 7 and 1. Or 7 and neg 1, and then we want two numbers multiplied together to give 2 out the front, 2x squared, so it's 2 and 1. So you can put 2x in there and 1x in there, and then you can see it, can't you, that if you have neg 7 and x and plus 2x, you would get neg 5x. So this is a reverse FOIL approach, rather than having to use this method up here, which is a bit long for this particular type of problem. Or you could use the x method, the cross method, couldn't you? 2 and 1, neg 7 and 1, like that. So 2x squared and neg 7, then 2 times 1 is 2, neg 7 times 1 is neg 7, and neg 7 plus 2 is neg 5 for the middle term. So there are a few different techniques. Okay, you know already though that you could have used the formula for the roots of a quadratic. So it makes factorisation a little bit antiquated now. You should be able to do it, but you could just go straight to the formula to get these two values. So this is the these are the two x values where the graphs have a common point. So substitute x equals 7 over 2 into either one, which is a common point. But let's use 2x plus 8. Why? Well, it's simpler to substitute 7 over 2 into there. And when you do it, you get 15. Substitute neg 1 into 2x plus 8, you get 6. So now finish it off with a statement in context. The graphs meet at 7 over 2, 15, and neg 1, 6. Okay, so realising that a point of intersection is a common point, you can equate the y's or the x's if they had expressions x equals, and then you can also, because of the commonality, sub into either expression to get the other coordinate. Okay, people often ask me, Huddy, which one do I substitute into? And the answer is it's a common point, so it won't matter. Okay, the relationship between y and x can follow either graph because it's a common point. That point lies on both, therefore that point satisfies both equations. Therefore you can sub the x value into either y's. Have you got it? Yeah, let's get up close and personal with what we're doing here, so it's not just learning stuff up by rote. Alright, let's go down and have a look at these here. So I think you should do all of these. And you've got some interesting ones here. We'll have to clear the denominators by multiplying by the common denominator. And that then will give rise to quadratic expressions, I think. We've done a bit of that already. Okay, so think about that one. Okay, common denominator. When you have some denominators floating in an equation, to clear them, to solve it, you multiply through by the common denominator. All right. Okay, let's have a look at the answers to those then and see what you thought. Okay, there are some answers. All right, now we also want to be able to do this with technology. So I've got a little bit of technology coming up down here. And here it is. Okay, this is on the Casio 9860 Plus. Great graphics display calculator. What do? Well, we go to graph mode, put the two functions in. I've got x squared take 4x and 3x here. You then hit draw or execute and you'll get the graph. You might have to adjust the view window. I'll put that in here. Adjust the view window. Okay, so that's what? That's Shift F3, isn't it? Yep. Shift F3 and just check that you've got the window. Or, of course, you can scroll around the screen with this and make it and go up or down, and so it comes into the view window till you've got that. And then from here, obviously you want to find a point of intersection, so if you Shift F5 then you get these options, and here's the one you want out at F6, I think that is, isn't it? So ISCT stands for intersection. If you hit F5 there, F6, sorry. No, what is it? Is it F5 or F6? Well, we'll just have a look, shall we? Haven't got that all up there. So I think just having a look, just checking it now, it's F5. F6 is the last one. So F5 for intersect there. Okay. All right. So let's have a look then at what happens if you do that. It pops on the first point of intersection there and tells you its x is equal to 0 and y is equal to 0. So that's nice and easy there. And then the next thing you might do is push this button to go across to the other point of intersection. Okay, moving across, and that's at 721. So your answers are 0, 0 and 721. Okay, fair enough. I think it's quite easy. You do have to get your two functions in y equals or explicit statements in x. Y is an explicit statement in x to use this method. Okay, here's some problems for you. Have fun with these. Oh, sorry. No, we've got to go back up, don't we? I want you to check what you did before. back up here. Yeah, check those. I didn't put them down the bottom. Check those with the calculator. Go back over it again and just see what you think. Okay. All right, leave you with it. We'll be going on with more of this quadratic and getting into higher degree polynomials finally, and that's a very interesting area of maths. So I'll catch you then. Cheers for now.